So today's daily question 131, palindrome partitioning. Given a string S partitioned as such that every substring of the partition is a palindrome. Palindrome is something that can read from left to right and read from right to left is the same. Return all possible palindrome partitioning of S. Example 1. AAB. The first is split to every word, every character, every chart. The second is AA is the palindrome, and then B. Example 2. A. Constraints. Length is not very long, 16. S contains only lowercase English letters, only lowercase. Let's draw it. A B. For any string that is greater or equal than length is greater or equal than 1, split every char into a standalone string is one of the partitioning solution. So this is the first solution, AAB, and then the second AA and B. To return two partitions, and the second is example 2 is just an A, so the return is only one element. Think of that. What is a palindrome? A palindrome is something that reads from left to right and right to left is the same. So there are two situations. First, if the count of some palindrome length, some palindrome strings length is even, then it is even, like this. We can split from here, and this is the same as this, and this is the same as this. Second, think that it is odd, not even. Then this is not considered. This is the same as this. This is not considered, no matter what is here. If this calculator equals this, then this is a palindrome. So the palindrome partition question can be solved by two steps. First, we need to use dynamic programming to get everything that is to get every split that is a palindrome. Then second, we need to backtrack. Backtrack is from the first character on, and find from the first split place till the last split place to check every character that is to check every palindrome. If the put the counter's palindrome string in our counter return value, and then start from here again till we come to the end. Then push the result to now, push the counter value to now, append the counter value to now return array, and then return the value. Two steps. First, need a DP to get every palindrome, every partition of the palindrome, every partition till this is the n plus 1 DP, two-dimensional DP. Second, we backtrack from the first letter. From the first split place to the last split place. It is split, not the string length is n, and the split count is the count of split place is n plus 1. Yeah. So when we consider the dp, it is from this split place to this split place, and we can check this the inner part of this is a palindrome. Yeah. And the dp transform is some if dp for dpij we need to consider the dpi plus 1 and j minus 1. If this is true and the strings I and j equal, then the dpij should be true. Yeah, set it to true, and the dp value we can set it default to false. So let's write it. 2 steps. First, dp and get every partition, and get every partition till the longest the 0 till n plus till n. Yeah, n from the most leftmost to the rightmost. Then second, we backtrack from the first split place till the last split place. 2 steps. Okay, let's write it. This question is very, very interesting. We can it's a perfect combination of dp and the backtrack. So let's write it. First, we do the dp and make every split in the dp data structure. And the dp should be n plus 1 plus n plus 1, 2 dimension, and every dimension is n plus 1. We set it to false by default, and we need to fill it that every split from count value to count is to set it to true. Then we can use this to extend to a size of 2. Yeah. Suppose dp 3. Yeah, we set this to true, and then we can set the dp when we come to dp 4. We check the dp 3 and it is true, and then we check the strings 2 and 3 is equal. Then we set this to true. Okay. Yeah, we set the split of any place from here to here to true and for the extent of left and right, and every one character string is a palindrome, no matter what this character is. Yeah, because it is odd, and we need to check the left and right. We don't need to check the middle. Then we fill the DP, the length. We set this line, we fill every DP with length of 1, and this line we fill every DP of length of 0, and we need to fill the length of 2. Start less or equal than n, then we add the length. The I is the DP that we need to be checked. Equal DPI equal DPIJ and the string. No, I need to I plus 1 and these two char equal, then dpi plus l to true. Then we set I plus l to true. Yeah. After that, the DP has been done. Then we need to make the backtrack. The backtrack need no return, and we need integer. We need to catch the string. And if I has come to the n, then we just return and we need to push the counter to append the counter to the return value, and then break the backtrack. J must start from I plus 1. J should be less or equal than n, because we are the backtrack is iterating the split index, and the split index can reach n. The split index can reach n. The calculate index should not reach n because it's starting from 0. Yeah, but the split index can reach n. DPIJ is this is the valid split. The string is in from split I to split j is the palindrome. Then we append it to count value. Count value I and the j minus I. J minus I is the length, right? And then we backtrack from the split place of j. After that, we need to revert the counter change to the change we have done to the count element. Yeah. Then we call the BT with the starting split index of 0. Everything should works. Yeah. So today's daily partition. Submit. Just submit. Okay. This is a very interesting question that has combined the dynamic programming and backtrack. This is the smallest question that combines the dynamic programming and the backtrack, and it can be split into two. Yeah, this question can be the palindrome partitioning question can be split into two questions. First, we need to check if the S can be the whole part of the S can be made into a partition. Oh, this is not very good, and because if we just need to check S, then all the inner part is lost. We need to get all the inner part. Now, first we need to get all the inner part of the dynamic programming. To use dynamic programming to check the any start to any stop split, the two split index from any start and to any stop, to check that it is a palindrome. Then after that, we need to do the backtrack, and the backtrack can be split into another question that is given a string S and the palindrome positions. Yeah, at this point we already know the palindrome index. Then we need to get use the backtrack to get all the return strings. So somewhat easy and but very combine everything very smoothly and very clearly, and can be split into different parts. So this question is great for dynamic programming and backtrack. Yeah. Something more to have a look at the solutions. Backtrack. Dynamic program backtrack. Yeah, backtrack. Oh, that is palindrome. Oh. Yeah, passing is much cleaner than the code is very short and clean. C++, the code is very long, and this is a trick. We can just backtrack, but no DP. Just use backtrack. Then we need to check everything from every step to check it is a palindrome. Oh, this is not good. Time complexity. The time complexity. At this step, the time complexity is n to the power of 2. Oh. Let's have a look. This step is on, yeah, on plus 1. This is on, and this step is 2 for. This is a triangle, right? This is a triangle. The first step, the first L equals 2. The inner loop should loop n plus 1 minus 1. Yeah, should loop n plus the first loop length equals to 2. The loop should loop n times, and then n minus 1, n minus 2, n minus 3. Yeah, until it is 1. Yeah. So it is n plus n minus n divided by 2 is n to the power of 2. This is the n to the power of 2 algorithm, and this backtrack. For backtrack, how to calculate the backtrack is the time complexity. For any index, we need to look for all the remaining. So suppose the index from start, just think of the AAB, just think of the AAB. Then the DP result is from here to here. This is okay, and this is okay, and this is okay. Yeah, the DP have 4 values. And for the first for the first split, this place the I 0, then we need to look for every value in our DP. Yeah, every value here. 0, 1, 2, 3, 1, 2, 3. We need to look for 3 and check the 0, 1, and then it matches. It is the DP value is true, so we push the count A into now first element and then look to the second. It is still A, still true, and the B and so the first return value is AB. Yeah. So time complexity should be imagine that the most all A, yeah, an array that is all the same, only one character, one char. Then for every backtrack is we need to push this and push this, and the second time we come to and get backtrack and get this. No. We are the backtrack is not this index but the split index. This index. Yes. So the first split is this, and then we come to this. This is okay, and then we come to this, come to this, and this is area G. And for this, when we come into here, this is not LM to the power of 2 solution. It's the time complexity should be n log n. Is it n log n? So this how many non-ops have we do to this? 4a. First time come with the I is 0, and we look to from 2 to n, and when we come to 2, from 1 to n, then we come to 1. The function has already been called once, and when we come to 1, then it is a tree, right? First we get the backtrack of 0. Backtrack of 0. Then the value is 1. And then we get the backtrack of there are many backtracks. So the first element is 1. The G is 1, right? And the G is 1, G is 2, G is 3. 4 elements. So there are 1, 2, 3, 4. Oh yeah, G is 4. So G is 4. Then we come to G. Then when one is matched the DP, the other one is true. Then we come to push the one in the return in the count and come to 2, right? Come to 2 and come to 2 and come to the same. Come to 3. Yeah. Come to 4. 1 have 3 children, and 2 still have 3, 4, 2 children, and then 3 have children of 4. Yeah. This is not a binary tree, but many. Every node have many. 3 have children 4. Yeah. So 2 is the same, and 0 is. So how many nodes are here in this tree? There are 1, 2, 3, 4. 2, 3, 4, 3, 4, 4. 3, 4, 4, and 2. 2 is 3, 4, right? 2 children, and 3 is 4, and 3 have 4 as its children. Then it works. Count how many children are, how many nodes are here. This is the most, the largest. This is, and then n is 4. N is 4. How many children are here? The first layer have n, right? The second layer for every n, n minus 1. So, and how many nodes are here? How to count the nodes in this tree? How to? Oh, so we just count it. All right. 1 and 4. 4, 5. 10, 11, 12, 13, 14, 15, 16. There are 16 elements here. N to the power of 2. Is it n to the power of 2? Is it n to the power of 2? So I don't think it's n to the power of 2. How many children are here? For any, suppose now we extend this tree to add 1 element, add a 5 here. How many works do we need to do? First add the 5 in this node, then add a 5 here, then add a 5 here, then add a 5 here, add another 3. For any 3 we need to add the 4. add 5 here, and you add 5 here. So many nodes added. How many? I don't know how to count how to calculate the time complexity of this backtrack. And have appreciate if you have any advice to calculate this tree's node. You can just give me leave me a message. Okay, thanks very much. And the space complexity is not very. It's the DP cost and the backtrack will not be counted, and this is not very large. And when right, and this is n to the power 2. So n to the power 2. Yeah, and this is omitted. Just Owen. Time complexity. I don't know how to calculate this. How to count the nodes in this tree. The tree is very complicated. I don't know how to come. If you have any advice, have any idea how to count the nodes here, leave me a message. Thanks very much. So today's data question, I will check the solution. Other solution is the time complexity. Our solution, 4 languages. Have a look at the implementation is Palindrome. Oh, they are using this to not DP, but if we use DP, how to calculate the time complexity? Dynamic programming. The DP is easy to calculate, but the backtrack is harder to calculate. Okay, so I will check it out at my n plus 2 to the power 1, 2 to the power 1, why? 2 to the power 1. Oh, I got it. There are n plus 1 split places, and every place have 2 steps. I have 2 states. It can be choose, not choose. So it's 2 to the power 1. Yeah. So this is the 2 to the power 1. And the n is the check. The check function cost n. Then the dp is 2 to the power 1. Oh, no solution that uses both dp and y. Use dp to calculate the splits. First is should be faster. If let's have a look at my 84. Not very fast. So any dp backtrack and the dp. Yeah, this should be the faster solution. And but how to n plus 2 to the power 1? Why? The estimate for TC of depth is as follows. You need 2 to the power n times of performing that pushback. Oh, sub STR. This is the ON solution, right? So this is then string operation cost n is palindrome. N to the power of 3. Why? 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 No, I just need to check the 2 chart and check the state and then the my solution is n to the power 2, but his to n to the power 3. So yeah. Then we DFS. But how to calculate the time complexity of this code? I am not sure. How to 2 to the power n and this n plus 2 to the power n. The backtrack is the cost in the bit is called n to the power of n times y. If no 4 here, then we just select every bit, then it is 2 to the power n, and then we have a 4. Okay, so this is today's delicacy to let it in the midnight. Thanks very much.